AWS Fraud Detector built a transaction predictor model based on past non-legitimate events. The analysis gives the probability of a scam transaction and requires manual review. You can read more about this topic on this book about data forecasting and segmentation using Microsoft Excel, linked to boy in Amazon on this post. Amplitude and Statistics, it is a participant of the AWS Activate program. So here we have the general introduction for artificial intelligence machine learning procedure to generate and test a prediction model steps. First, we have a group of data that have several characteristics, and we have an event label classifying this data as a legitimate transaction or a fraud transaction. This is the input data that the model will use to design and train what we are going to use to predict the future values. Okay, so in this example we have several online registrations where we have several characteristics like the IP address from the customer, the email address, the billing state, user agent, like for example if it is the Mozilla or Chrome or mobile browser, what is the billing postal, the phone number, the event timestamp, and the billing address, with the result if it is classified as legitimate or a fraud transaction. Okay, so we have all these characteristics, and we are going to use this as an input to generate this model, where we are going to classify this model or the model accuracy, and the AWS will include the model accuracy and a matrix called a confusion matrix based on 100,000 events. It could be less events, but it is calculated proportionally to 100,000. Okay, so here we are going to get what are the total fraud transaction or the true positives. The true positive, it is defined like the transaction it is an actual fraud, and the model predicted this transaction as effectively a fraud transaction. So this is the true positive, and we have the next, it is that we have a legitimate transaction, and the model actually predicted it is a legitimate transaction, so it is a true negative. So we are going to evaluate if we can use this model. For example, if what is the accuracy of the true positives, and what will be the error of the model qualifying legitimate transactions as fraud. Okay, so this is what we are going to evaluate if the model is working for us or not. Okay, so here we have the confusion matrix. First we load the data, like the data that we explained before. We have this, in this example we have 94, 90, 96 legitimate against 5,004 frauds. Okay, for a total of 100,000 transactions. Okay, so this is the universe of data that we get. So the model performance after AWS trained the model, it has a high qualification of 0.95, closer to 1. It means that the model it has a high accuracy. Okay, so this proves that the data that we are using as input, it is working and it is useful to make the predictions. Okay, so first we are going to see this line. This line, it is about the fraud transaction. This is the fraud transactions. Okay, the total fraud transactions are 5,004. These are the total fraud events, and the model, it is doing a success prediction of a fraud transaction as fraud for 4,689 events. Okay, so this is the number the actual number of frauds, and they have been detected by the model as effectively they are a fraud. Okay, these 4,000 events are equal to 93.7% of the 5,004 fraud transactions. Okay, the rest the model classified as legitimate events. So this is the error that we are getting from the model. Okay, so the error for this model are 315 events of the 5,004 are classified with an error as a false negative. Okay, so we are looking for the efficiency of the true positive. Okay, when the event it is an actual fraud and it is a predicted as fraud. Okay, so this is the true positive, and we have a true positive rate of 93.7%. Okay, so this is working very well. This is about the fraud events. The legitimate events, we have 996 legitimate transactions, a total, and from them the model are classifying the actual illegitimate as legitimate transactions. So it is the success prediction of legitimate transactions for 782 events, and these are equals. Okay, so we are getting this success prediction for these transactions qualify as true negative. Okay, then we have the false positive. That means that the transactions are legitimate, but the model classified them as a fraud. They are 12,214 false positive. Okay, this false positive is equivalent to 12.9% of the 94 legitimate transactions. Okay, so this is the error that we are getting classifying legitimate transactions as a fraud. Okay, so we have to evaluate our model. Okay, when we get this response, that means that we are catching the 93.7% of frauds event as a true positive rate, but we have to accept this risk of a false positive rate of 12.9% that classify legitimate transactions as fraud. Okay, so that means that every 100 transaction we are going to have a success of 93% catching the fraud events, and we are going to fail on 12.9% of our data. Okay, remember that that we are speaking about this 93.7%. It is equivalent to the total fraud transaction of 5,000. Okay, we are speaking here of the true positive event just about the fraud transaction of 5,000, and this 12.9%, we are speaking about the 94,000 legitimate transactions that we have here. Okay, so that's why you can ask that these two percentages are not assuming 100, because they are not referring to the same number. This number of total positive rate, it is referring to the prediction of the total fraud transaction, and this number of false positive rate, it is referring to the total legitimate transactions. Okay, so we have this idea of this model that we are going to be effectively catching 93.7% of the frauds, okay, against 12.9% of legitimate transactions, the model will classify them as a fraud. So they are like false positive. Okay, so that's why that's how do we qualify the accuracy of this model. We are going to see that the model also assign an importance value to the variables that are more important to the prediction. In this case, the most important variable, it is the billing state. Okay, it is the billing state that determines more if the transaction is a fraud or not. In second place, it is the billing posto. Okay, in third place, it is the user agent. So you can see that the type of the browser that the client is using, it has it occupies the third place that in determination of if the transaction is a fraud or not. And in fourth place, it is the email address, and you can be surprised of this. In fifth place, it is the IP address. So it is more important the billing state than the IP address to determine if the event it is a fraud or not. Here we have the chart of the positive rate. The positive rate, remember that the positive rate, it is the total positive rate here. It is the rate that determines the true positive, that determines if an event is a fraud. The model classify effectively this as a fraud. Okay, so this is the true positive score. Okay, the event is a fraud, and the model classify effectively this as a fraud. Okay, so when we make an input of a transaction or an event, the model will return a score that goes from 0 to 1000. Okay, so we are going to design a response that if the value it is between 800 and 1000, that means that we have to review this transaction, because in that case we are getting just the 60% of probability. Okay, that this is the event that we are that the event it is a fraud, and effectively it is it is uh, it is a fraud transaction. Okay, so if we get this high score in the model, we have to review this transaction, but because because we have a chance that this is a fraud. Okay, if we get a response from 500 to 800, okay, the range of value varies from 80% to 93%, that the fraud it is effectively classified as a fraud. Okay, effectively this is an actual fraud. Okay, so in this case we want to raise an alarm also, just to make a soft review of this event, because we are getting like a soft calling with this percentage. And when we get a value between 0 and 500, the score goes from 93 to 97%, that that the response of the model has this high probability. Okay, so if we get on this range, for example, that the transaction is valid or legitimate, it is probably true. For sure, it has a 93 to 97% that the model accuracy it is predicting that the transaction is legitimate. So we can classify this event as legit. Okay, so that's how do we make a classification of the response or the score that we are getting from the model when we test this or when we run the model with a new record. Okay. We can also use the fraud detector for marketing campaigns to see all these characteristics of our clients. For example, age, job, marital status, education, balance, and if it has a housing or not. And here we have the response as if this client buy an a buy a product from us or he didn't, and the model will make this prediction. Okay, so we can use also the AWS fraud detector to measure the marketing campaign. Now we are going to see a video of the implementation of the AWS fraud detector. We need an S3 bucket to store the data that we are going to use. Then we are going to build an event data set from the S3 buckets. Then we build a machine learning model, and finally we are going to build a detector and get the predictions. Okay, so here we have the response of here we have all the responses that we are getting from the confusion matrix that we saw before. This is the true positive and the true negative that we were speaking before, of the false positive rate and the true positive rate, compared with a base of 100,000 records. Here it is the model that it is classifying what is the variable that has more importance to the model. Okay, so this is how do we run this test. And finally we are going to see in the next screen how do we make an an input of the new data. For example, we are here entering the billing, the address, the postal, the IP address, and then we run the test, and we see that we can approve this transaction because the model returns a value of 272. And if we move here, we can see that we have an accuracy of the model of 95%. That means that we can approve this event as legit because the model is returning a very high accuracy, a very high percentage of success. Okay, so the last slide, it is the fraud detector model. We have to build an event dataset, build a machine learning model, and then we run and test and build a detector and get the predictions using the fraud detector model.